last and second last was join and Cartesian product.
Yes, sir.
Am I right? Okay. Now we are going to discuss a puzzle. That puzzle will show.
सर कार्टेशियन प्रोडक्ट का पूरा नहीं हुआ था सर, आइदर का फर्स्ट हुआ, इफ आइदर का फर्स्ट कंडीशन लिखा है तो वहीं पर।
Okay, okay, just I am recalling the again, join and Cartesian product of both. Okay, so I am just join means suppose G1 and G2 are two graphs, then the join of this will be G1 plus G2, whose vertex set will be, vertex set of G will be the union of vertex set of G1 and vertex set of G2, and edge set of G will be the union of edge set of G1 union edge set of those is vertices, such that U belongs to VG1 and V belongs to VG2. Okay, so this one is the definition of join, and second one is the Cartesian product. Cartesian,
सर कोई ज्वाइन होना चाहता है सर?
wait, okay, yes, Cartesian product. Okay, it will say that again, if G1 and G2 are two graphs, G1 and G2 two graphs, then G will be the G1 cross G2, whose vertex set of G will be the product of G1 vertex set and product of G2 vertex set, and edge set of G will be such that if XY comma UV will be belongs to G1 cross G2, such that two distinct point XY and UV of G1 cross G2. G1 cross G2, condition here is are adjacent okay, or adjacent if either first condition, what is this, u equal to x and vy belongs to edge of G2 graph, or we can say second condition, v equal to y and ux belongs to EG1 set. Okay, so these are two operations. Okay, for first we can say the example. Suppose I have a graph like this way. This one is graph and second one is this graph. Okay, this is G1 and this is G2. Then according to definition of join, it will be given, it will be here and also it will be here. Okay, this is G1 plus G2 graph, and suppose I want to find the product. Suppose I have a graph G1 and suppose I have a graph G2. G2 graph, then the graph like this way. Wait. Okay, just we can take, there are three vertices and also there are three vertices. We can take the copy of these three vertices. Okay, and we can take the copy of like this way. Okay, okay, so there are three vertices, 1 2 3, and this graph has also three vertices, so we can take the copy of G2, add the three according to vertices of G1. So there are three vertices, I have to take the copy of G1 like this way, and just you can join the vertices which are adjacent. Okay, so how to join these vertices? So this will be the adjacent, this vertex, and this vertex will be the adjacent, these vertex will be adjacent, and this vertex will be adjacent. Okay, and again this vertex and this vertex will be adjacent, and again this vertex and this vertex will be adjacent. So this is G1 cross G2.
G2 क्रॉस G1 कैसा होगा सर, सेम होगा कि डिफरेंट होगा?
Yes, same.
G2 क्रॉस G1 भी सेम होगा?
Yes.
हर केस में कि इसी केस में?
नहीं, हर केस में.
Thank you.
Okay, now I have some work for you. That one, your answer will be here again. Your assignment here, find M fold. M fold. For what? Union, join, and product or Cartesian product या Cartesian product. Okay, union means suppose I have a graph G, then G1 union G2 union up to Gm, join G1 plus G2 plus G3 up to what will be the here? It is like this way. Up to Gm. Product G1 cross G2 cross G3 up to Gm.
सर अलग अलग ग्राफ सर अलग अलग वर्टेक्स उसमें हो सकते हैं, वैसे एजेस के नंबर भी चेंज हो सकते हैं सर। जो प्रोडक्ट वाला जीएम वाला है सर, सर उसमें सर अलग अलग मतलब एजेस और अलग अलग नंबर तो वर्टेक्स हो जाएंगे ना, तो मतलब जो आप असाइनमेंट उसमें
ये डिफरेंट ग्राफ्स हैं। ओके, ये सब डिफरेंट ग्राफ्स है। यू हैव टू टेक द कॉपी ऑफ दीज, copy of these. I am saying that these will be same here. G1 बराबर equal to G2 बराबर up to Gm. Yeah, just you can say that you can take the M fold. M fold means or a M fold means just you have to union two numbers, means you have to find 2G. Okay, and same here. This will be again. I think it will be here will be a problem. Union means just it will be the again itself G. Union of all will be here only this one. For example, suppose I take this graph. This is P2 graph. Okay, and what is the union of this one? P1 again. This is P2. So what is the union of P2? Again it is this graph again all. Okay. So it means that union, there is no meaning. I think there is no meaning from M fold for union. Okay, just there are methods, means there are meaning for joint and Cartesian product of a graph. Okay, so you can skip, you can remove this one, because intersection and union, if you take the intersection of a graph that it will be again that graph. Okay, I mean to say that union of M of G will be the union is equal to, and also intersection of G is into G. Intersection means common and union means all. So I think they will be equal. Okay, if you take the intersection of this, what will happen? Intersection P2 P2, just common, and common will be this only. Okay, so you have to find joint and Cartesian product only. M fold. Okay, now we will discuss a puzzle. Okay, in which we can say that how a problem can be solved by using the graph theory. How a problem, or that problem may be physical problem, chemical problem, mathematical or a biological problem. Okay, it may be any problem. Okay, just we have a problem. Okay, how a problem can be solved by using the graph theory. Okay, so for this, so we have basically two steps. So what is the first step? In the first step, which problem we are taking the problem which are taking, we have to convert this problem into the graph theory problem. Okay, first one means the problem is converted into the graph theory problem. Problem of graph theory. Okay, in the second step, what will we do? In the second step, now problem is graph theory problem. The graph theory problem is then solved. Okay, in the second step, graph theory problems, this one can be solved. It can be solved with the help of graph theory. So by concept of graph. So basically, what is the meaning? That first of all, we will consider a problem. That problem can be from biological science, chemical science, or physical science, and whatever the sociological science also. Okay, so and physical science means problem from the electric networks, chemical science from the isomorphism, to find the saturated isocarbons, that will be the chemical problem. And also for sociological problem, like to separate the card, and also by localizing the or we can say that to discuss the measure center in any locality. Okay, to measure the center of any locality. Locality means a colony. Suppose we can see that a colony. Okay, so there are a lot of problems in the nature. These problems, first one, we have to convert these problem into the graph theory problems. And after graph theory problem, suppose we have a graph theory problem, then with the help of the concept of the graph, we can solve that problem. Also, in the third step, we can verify, we can implement this theory to any other problems. So for this, I have a problem. I have a puzzle problem. Okay, so basically, this puzzle problem is also called the instant insanity problem. This problem is also called instant insanity problem. Okay, this is also called instant insanity problem. Okay, it is a puzzle problem. And also this is called, the puzzle problem is multicolored cube. Multicolored cubes. Okay, so this is the name of this problem. So what will you do? So first of all, we have considered a problem. That problem is the multicolored cube problem. So what the problem? First of all, we have to discuss problem. What is the problem? Okay, means what is the problem? So problem, what is the problem? Suppose we have 4 cubes. We have 4 cubes, and you know that each cube has 6 faces. Suppose I have a cube like this way. Okay, I have a cube this way, and you can see that this cube has 6 faces. Okay, so this is the top, bottom, okay, top, bottom, front and back, and left, right. Okay, so there are 4 faces of a cube. Got it? And every cube, suppose we have how many cubes? We have 4 cubes. Okay, I have take 1 cube. This is the 1 cube. Okay, this is the 1 cube. And every cube, there are 4 cubes in which I have taken only 1 cube. Each cube are variously colored, or we can say that each face of the cube is colored by 4 colors. Okay, for example, so this cube can be represented like this way. Here, so I'm writing here, I'm saying that left and right. Okay, so suppose this there are 6 faces, 1 2 3 4 5 6. These are the 6 faces of this cube. Okay, this is the 6 face of this cube. In this case, we can see that this one represent, this face is represent the top, and suppose top face is colored by blue color. Okay, and this face is represented by the bottom, and bottom is colored by white. Okay, same here, this is front and back. These are the cubes, these are front and back cubes, and also which are colored by red colors. And again, this one is the left and right. This is also colored by this face is also colored by red color, and it is colored by blue. Yes
सर, राइट साइड वाला फिगर समझ नहीं आया, और एक बार एक्सप्लेन कर दीजिए.
Okay, I am saying that this is the cube. Okay, this cube has 6 faces. Got it? So I can I can write this cube like this way. In this way, what is the reason? There are 6 faces, 1 2 3 4 5 6. Okay, these are the 6 faces. We can say that this face is the top. Okay, so this is the top. So what is the bottom face? The bottom face will be W, or we can say the opposite face. Opposite face of this cube is W. W means white. It is colored by W. It is colored by white color. It is colored by white color. Got it? And this face is represented front and back of a cube. This is the front and this is back. So this portion, if you see, this portion is the front and this portion will be the back, and these two opposite face are colored by red color. Okay, same here, these are the left and right face of a cube. Left and right, or we can say opposite of left and right. These left and right are the opposite to each other. Suppose these are the face which is denoted by R and G. Now, is it okay? This is cube 1. Are you getting my point? Okay, now question is that suppose we have 4 cubes whose 6 faces of every cube are variously colored with blue, green, red, and white color. And problem is that, is it possible to stack the cubes? Now we have 4 cubes, so this is 1 cubes. Okay, we have to stack these cubes. Suppose like this way. Okay, this cube, this is 1 cube, this is C2 cube, this is C3 cube, this is C4 cube. We have to stack these 4 cubes one on top to another to form a column like this way, to form a column such that no color appear twice on any of 4 sides of the column. It means that if we see any 4 side, because this is the column and basically it is formed by the 4 cubes. If you see from any direction, you can see from left, right, front or back. Okay, if we can see, if we see this column from right, left, front and back, from each side we have the different colors. We have the different colors, means there will be the different colors. But question is that, so can we arrange, can we stack such cube, such column from these cubes which is colored by 4 color? Are you getting my question?
Yes, sir.
Simply I am again repeating we have 4 cubes. Got it? Like this way. We have 4 cubes and each cubes has, each cubes has 6 faces and each face is colored by 4 color. Okay, each face of the cube is colored by 4 colors like blue, green, red or white. Problem is that, question is that, is it possible to stack these cubes one on top of another to form a column such that no color appear twice on any of the 4 sides of this column? Okay, by using the
base or top,
what?
the base or
Hello?
top sir मतलब different current होता है. So
No,
bottom or
no
top.
need, no need to discussion about the top and front. Just we have to see that column from any direction, because there are 4 directions: left, right, back and front only. We will not emphasize on the bottom and top. Got it? We will ignore top and bottom color. Just we have to see,
Okay.
we have to see that column from any 4 direction. From any 4 direction.
पॉसिबल है फिर तो,
क्या
पॉसिबल है देन तो?
ऐसा पॉसिबल है?
हाँ सर,
हाँ पॉसिबल है. हम कब मना कर रहे हैं कि इट इज नॉट पॉसिबल?
नो सर, आपका क्वेश्चन का आंसर
ओके ओके
साइड
ओके
में एक कलर.
yes yes it is possible. Okay, you are saying the answer. Okay, got it. Okay, so it is possible. Okay, but if you use the mathematical method, by using the trial and error method, then you will see that you have to try 4, 7 2 times to arrange such column. Okay, you have to try 4, 1, 4, 2, 4, 7 times to arrange these cube in such type of a column. But with the help of the graph theory, it will be easy. Okay, the question is that how we can formulate this problem into the graph theory problem. So first is the problem. Second step of that will be the formulation. So what will we do? So I'm saying that we have 4 cubes. This is the one cube. Suppose I have 4 cubes. I'm making the 4 graphs, 4 cubes again. Okay, so this is first cube, this is second cube, this is third cube, and this is fourth cube. And the faces of first cube is colored by red, blue, green, white, red, red. Okay, second is colored by W, G, B, W, G, R. Okay, this is R, B, W, W, R, and G. And this is colored by G, G, B, G, B, R, and W. Okay, so these are 4 cubes, and each face is colored by 4 colors. Okay, in the first cube, there are 3 red color and 3 different. In cube 2, there are 2 green and 2 white, total number of 4. And in the third cube, there are 2 whites, 2 red, and in this case there are 2 blue faces and 2 green faces. Okay, total number of faces are 6, and each face is colored by 4 color. It means that some colors may be more than 1. Okay, some mandala face will be colored more than 1, but it is always less than 3, because we have to need 4. So how to draw a graph from this? So now to draw the graph from these 4 cubes, we can take 4 vertices. We can take 4 vertices with the color, taking the color. So we can take 4 vertices. Here it is, suppose B vertices, R vertices, W vertices, and G vertices. Okay, because we have 4 colors, so we have take 4 vertices. Okay, now what will we do? Suppose we take first cube. First I will take first cube here. This is the first cube. Okay, I take the first cube, and we can see the faces of this first cube, and we can join these vertices vertices between those colors, yeah, just we can say that in Q1 white face is which is the opposite to each others, which face is opposite to each others, we can draw a line between these vertices. Okay, for example, in this cube the opposite of R will be, what is the opposite of R? This face. Opposite of this face is green. Okay, so it means red and green. Opposite of this, red and green. Red and green. Okay, I am talking for first cube. So R is opposite to this, so I will write here 1. I will label this as by 1. Again, what is the opposite face of this? These are opposite face. R is opposite, means it is top and front and back. Front and back, these are same colors. Okay, so it means that we can take a loop, and also this is the edge, and I will label this as again 1. Okay, now come to this. This is the top face and it is the bottom face. Okay, so opposite of top is white, means bottom it is colored by B and it is colored by W, white. So B and W, it is also represented by 1. Is it clear?
Yes.
Now come to the second cube. Now you can see that opposite of W is G. Got it? This is 2. Opposite of B is W. B, W, B, W, B, W. Okay, and opposite of one more is GR. Okay, this is G, this is R, this is G, this is R. Got it? Now come to 3 cube. R is opposite W, R is opposite to R is opposite to W, R is opposite to W. Okay, white is opposite to green, white is opposite to green. Okay, and B is opposite to R, B is opposite to R. Okay, and fourth one, B is opposite to R, B is opposite to R. This is 4. B is opposite to W, BW, BW, and G is opposite to G. Okay, so this is the formulation of the problem. Means our physical problem is formulated into the graph theory problem. Is it clear? And now you can study this graph. We have obtained a graph, this one. Now you can study. This means this graph has 4 vertices and each vertex have some degrees. Okay, for example, this vertex has 1 2 3 4 5 degrees. Okay, and total number of edge of this graph is 12, and also you can find the degree sequence of this graph. Got it? So now with the help of this graph we have to find the solution. So next heading of this problem is solution. First we have the problem, second one we have the formulation, and third one we have to find a solution. So solution, what will be the solution? So solution of such type problem will be exist. It is okay. Got it. Now we have, what is the formulation, solution. Okay, so what will we do? We have the solution will be exist. The solution of that problem will be exist. Okay, okay, solution okay, so solution will be exist. The existence of the solution will, if we can find okay, the solution of this problem is exist solution of problem is exist if and only if and only if there exist two edge disjoint subgraph there exist two edge disjoint subgraph, each with 4 edge, each with 4 edge, each of the edge labeled differently and such that each vertex is of degree 2 and such that differently and such that each vertex is of degree 2. Okay, so I am saying that I have this problem. Okay, this problem is formulated into the graph theory problem. Okay, so such type, this problem has a solution if the problem has a solution, the solution of the problem is has a solution if there exist two disjoint subgraph, each with 4 edge, and each of the edge labeled will differently and such that each vertex is degree 2. Okay, so this is the condition. This is the condition for the existence of solution. Okay, okay, means if this condition hold, if it means that if there exists two graphs such that with 4 edges, each of the edges labeled differently and each vertex has degree 2, okay, then our problem has a solution. Okay, so I have already discussed what is the edge disjoint subgraph, what is the degree of the graph, and each of the edge labeled differently means each edge means we have to find a subgraph, we have to find two subgraph. Okay, and each of the edge labeled differently means 1 2 3 4, each subgraph has 4 labels, 1 2 3 4 1 2 3 4 1 2 3 4. Okay, so you have to find two edge disjoint subgraph of from the graph we have formulate. Got it? Got it? So this is your work, and hello, are you getting my point?
Yes, sir.
If you have any problem, let me know.
No, sir.
No. Okay. Okay, so just you can verify. You can verify that. B R W G 1 4 2 3. Okay, again W G R B. But in this case, you can say B and W. Its label is 1, but in this case 4. 1 3 2. Okay, so this is the first graph G1 and this is second graph G2, and you can see that these two subgraph are edge disjoint subgraph and each vertex has degree 2 and each edge has different label. Got it? This edge B2 are, there are 4, and but in this case there are 3 labels. In this case it is 1 level, it is 4 level, it is 2 level, it is 1 level, it is 3 level, it is 2 level. Okay, now you have to stock. How to stock? You have to think, give the answer. Okay, tomorrow you will provide me the answer how to stock these cubes. Okay, okay, now I stop here. Tomorrow we will continue.
सर इसको शेयर कर दीजिएगा.